Yes, good evening. You are welcome to my YouTube channel once again. So this is the part two of the semi-detached structure that we are working on. Now, for the part one, we were able to do the general arrangement and teach you the principles of GA, which is this general arrangement. Now, for the part two, we are going to be exporting the model. We are going to be designing it. We are going to export it. We are going to model it, run the design and the analysis, and if there's time, we are also going to do the detailing. If we don't do it in this part, then we'll do it in the subsequent parts. Now, what we are going to do now is to export the model to the software. And how do we do that? The first thing we need to do is to put this document in DSF file. And how do we do that? Follow me. So you click on W block. Once you click on W block, it brings out this dialog box. Now, what it's telling us now is that it is in document, that the file is going to be in document. The name of the client is Ben. So let me save it as Mr. Ben. Let me save it as Mr. Ben. Then I click on OK. No update has been selected. So, okay, sorry. The first thing you do is to select the object. After selecting it, then we'll click on W block. After clicking on W block, then we'll rename it as Ben. Let's just name it as Ben Proch. Ben Proch. Are we together? Then we'll click on OK. So it has been done. Then let's now go to the software. Now, once we get to the software, let's create a new project. We'll click on new project. So let's name it Ben. Let's name it Ben Project. Then let's now go to the code. I'm using VS Code. So let's click on OK. Now let's wait for it to load. Yes, let's wait for it to load. Now that it has loaded, then let's now export the general arrangement to the software. So we go to building setup. We'll click on external reference drawing. Then we'll click on add. It's in document. Remember, I saved it in document, so I name it as Ben Project. So let's click on open. Then after that, let's wait for it to load. Now it's here. So we'll check this. You can see from the background that we have something happening in the background. Now it's now time for us to now import our axis and our columns. So for the axis, let's check it. Now for the grid, just remember in the part one that we named it as axis. So make it axis. For the column, also remember that we also named our columns as column. That is we selected the layer property of column. So we'll click on column, then we import. Click on column, then we import. So wait for it to import. Yes, it has imported. Then we'll click on what? Close. Very good. Then we'll click on OK. Voila. You see that our general arrangement has been exported to the software. Our general arrangement has been exported to the software. Very good. Now, the next thing we need to do now is to what? Is to now model our beams and our slab, right? Is to model our beams and our slab. Now, for us to do that, let's click on model. Let's go to beam. Now, we'll be starting with a beam of 230 by 450. Then from there, we can now proceed to increase it to 600. From there, we can now proceed to increase it to 600 if the 450 beams fails. If it fails in deflection or if it fails in shear. Now, let's now draw our beams. Let's draw our beams. Let's draw our beams. Yes. Let's draw our beams. Yes. So let's draw our beams. Let's draw this. Yes. So let's draw this. Let's draw this. So let's draw this. Okay, let's say yes. Let's say yes, but I want this to be a primary beam. I don't want it to be split. I want it to be a primary beam. Why this one acts as a point load on the primary beam. So let's click on this. Let's go to properties. Now let's click on this. So we'll say no because we want it to be a primary beam. Then this is showing that this beam is a cantilever, which is wrong. Is actually fixed at both ends. So we'll click on delete. Are we together? So let's come here. Let's click on properties. Let's click on properties. Then let's put this here. Then let's draw this also. Let's draw this also. Are we there? Then let's draw this. Let's draw this also. Yes, very good. We are going to come back to this. We'll come back to this. Now let's do the same thing for this. Let's draw our beams. Let's draw our beams. Yes, let's draw our beams. Yes. Now let's draw our beams here too. Yes, let's take this up. Yes, let's come here. Okay, this one is actually projecting all the way down. Very good. Okay, let's draw this. Let's draw this. Let's draw this. Yes, let's draw this. Very good. Are we together? Okay, the same thing is happening here. So let's delete this. Let's delete this. Let's delete this. I want this to be a point to be a primary beam. Why this acts as a point load on it. So this is yes. So let's bring this here now. Very good. Very, very good. You see that our model is actually coming up gradually. Our model is what is actually coming up gradually. Okay, no. Let's draw this first. Don't worry, as time goes on, I will show you, because what this red arrow is showing you is telling you that it is a cantilever, which is not correct actually. Let's delete this. 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 Yes. Now let's place this here. Now you see now that it will show you a cantilever sign again. Can you see? So let's bring this here. Let's bring this here. Let's bring this here. Very good. Very, very good. Let's bring this here. Very good. Very, very good. See that it's actually coming out very, very nice. It's actually coming out very, very nice and very, very fine. Can you see that it's actually making a whole lot of sense now? Can you see that it's actually making a whole lot of sense now? So let's come to this now that we left. Let's come to this that we left. So let's place this here. Then let's get the center, shift F2, 112.5, enter. Then let's click on escape. Then let's click on this, properties, we draw this, drop it here. Very good, very, very good. This very, very good. Yes, I see that the model is actually coming out very nice and neat now. Can you see? Can you see? Okay, so let's come to this now. The same thing we did. We'll click on offset, drop it here, click on shift F2, 112.5, then place it, enter. Are we together? Let's click on properties. Let's click on properties and let's drop this here. Very, very good. Can you see that we are almost through with our beam? So this is not needed. That was just done to just get our center line. Now let's come to this place. Now remember I told you in the part 1 that these beams here are actually going to be transfer beams. So let's click on this now. What I mean by transfer beam is that we'll have columns that would actually be starting from that beam. Those columns are floating columns. They won't get down to the foundation. So let's get the center line, shift F2 minus 112.5. Okay. Now let's do for these two. Let's come here. Let's offset. Let's come down here. Then let's go to shift F2 112.5. Enter. Very good. Very, very good. Very, very good. Now Let's click on this now. Let's click on this. Let's click on this. Let's click on this now. Let's click on this. Yes. So let's model this too. Let's model this. Yes. Let's model this. Very good. Can you see that it's actually coming out very, very nice? Let's model this. Let's model this. Let's model this. Now let's go up too. Let's go up. Let's come here. Let's model this. Let's model this. And let's model this. Very, very good. Very, very good. Yes, it's actually making a whole lot of sense now. The structure is actually coming out very, very nice now. Now, um, I need to explain something to you, but I don't want this video to be very, very long, because this video we are going to do structural, this modeling, analysis, design. Then if you have any member that failed, I will check you, as I will teach you how to fix failed members of beams, slabs, and columns. So what I'm going to do is this. I'm going to explain the principle of me actually fixing, actually hinging beams now. What I want to do it now, I'm going to explain it to you in detail in in a video that I'm going to do, and I'm going to post it on YouTube with examples and other examples, but not a full model like this. Now, this is what I'm going to do now. Just watch along as I do. Now, I want to hinge the beam to the left. Hinge at left end. Apply to selected. Now, the reason why I'm hinging the beam to the left is that if you don't hinge the beam to the left, if you don't hinge this beam here, the software default setting sees all the beams as fixed, which is not correct, because this place is not transmitting any moment. This place is not transmitting any moment. So this place is supposed to be pinned. It's supposed to be pinned. Why this place is also supposed to be pinned also. Now let's hinge. Now let's update. Let's hinge to the right now. Can you see? So what I just did now is to pin this place and to pin this place. Why? This place is continuous, so this place is fixed. Now let's come to this place also. This place also is supposed to be pinned. The default setting of the software is that all the support condition of the software are fixed, which is not correct. Like this one now, this place is pinned, is not actually transferring any moment. So I'm actually going to hinge it. Are we together? The same thing is applicable here too. I'm going to hinge it here. Hinge to the right. Are we together? So now let me now take my time now to now hinge everything, or let me pause the video. Hinge it, then when I finish hinging it, then we can now come and continue with the lecture. I'm coming. Let me pause the video now. Okay, so I'm through with the hinging of the beams to actually make it paint. Sorry, I just want to confirm if this is recording. Okay, very good. To actually make it paint. So the next thing we're going to do now is to insert our slabs now. We're actually through with the modeling of the beams. So we'll click on slab. It's actually asking us for the location. You click on OK, then you click on load generator. Now, because it is a one suspended floor, so we don't need to check the lateral load combination, which is the horizontal load combination. So steel and concrete, yes, grade factor steel and concrete. So we'll just click on OK. Click on OK. So you see it has created 1.4 by 1.6 factor. So click on OK. Then it brings out this dialog box. I want my slab thickness to be 150. Then my load is actually an imposed load because it is a residential building. That's why I'm actually putting 1.5. Yeah. So That's why I'm putting 1.5, because it is an imposed load. Now, let me teach you how I estimate my dead load. Now, I want you to pay very close attention to this. Very, very close attention to this. This is the software that I use for my load estimation. I have the software for solid slab, flat slab, and I also have it for rip slab also. I have it for this rip slab. Everything has already been programmed already. Everything has been programmed. So let's go to that of the solid slab now. Now, for this solid slab, now remember that to get your load in kilonewton per meter squared, is supposed to be density times the thickness of your material. Now, let's take it one step at a time. For the self weight of the slab, which is concrete, the density of concrete is what? 24. 24 multiplied 24 kilonewton per meter. So 24 multiplied by the slab thickness, which is 0.15. So 24 times 0.15 gave us 3.6 kilonewton per meter squared. Now, let's come to the screed now. The density of screed is actually also 24 kilonewton per meter. Are we together? Now, it's actually 24. So 24 multiply, I'm actually proposing a screed of 50 millimeter, which is 5 centimeter for my screed. So 24 multiplied by 5 give me 1.2. Now for my POP, I'm actually proposing, of course, my POP can be more than this 25 mm, which is plaster of Paris. Now, the density of my plaster of Paris is actually 10. So 10 multiplied by 0.025 gave me 0.25 kilonewton per meter squared. The same thing as my ties. Of course, the thickness of my ties cannot exceed 30 millimeter squared. So 30 millimeter squared times the density of my ties, which is 26, times 0.03 gave me 0.78. So the total of it gave me 2.23, and that is the 2.23 that you see here. Then my partition allowance is 1.5. So the sum total of everything here gave me 7.33. Now this 7.33 now, how do I now put it inside the software? Now this 7.33 now let's go to calculator. This is a calculator. I have a total dead load of 7.33, but the software has already calculated the soft weight, which is what? 3.6. So I'm left with what? 3.73. So I will now go into my software now and put what? 3.73. Are we together now? Then I'll now start putting it in the panels. I'll start putting them in the panels. I'll start putting them in the panels. Start putting them in the panels. I'll start putting them in the panels. I'll start putting them in the panels. Start putting them in the panels. I'll start putting them in the panels. Start putting them in the panels. Very, very good. I'll put this to here. Very good. Now you see that I've actually placed my slabs in the panels, but there's something that I want to explain to you. If I put my mouse here, now, you see that the boundary condition is type 1. In some cases, we can say case 1. For those that knows how to design manually, this one is also type 1 also, which is wrong. So we can't say that all the boundary conditions are type 1, because in this lab now, we have case 1, case 2, case 3, case 4, case 5, case 6, even case 7. So, and how do we now make sure that the software gives us a true reflection of the end condition of the slab? Now, you will come to modeling, then you will click on set slab type automatically. Yes, you will click on set slab type automatically. Once you click on set slab type automatically, it automatically sets the slab type for you. Now, if you could remember that this was formerly case 1, type 1, now is now type 4, which is a true reflection of the boundary condition of that particular place. This also was formerly type 1, is now type 4. Now, I'm looking for an interior panel. I don't think we have an interior panel here. I don't think we have an interior panel. Okay, I don't think we have an interior panel. Okay, this is type 7. Now that is that for the slab. That is that for the slab. So If you place it, you see you have a dead load of 3.73, you have an imposed load of 1.5, then you have a self weight of 1.5. Very, very good. Now, the next thing is for us to put our dead load on the beam. And how do we go about that? To put our dead load on the beam, you click here, then you click on what? Edit load. When you click on edit load, now the headroom of this particular structure is actually 3 meters based on the architectural drawing. The headroom is what? 3 meters. Now, then you now come to wall load. Come to wall load. Once you come to wall load, now the unit weight of a 225 block is what? 2.87. But if we take only the unit weight of a 225 block, that shows that we are not doing justification to the plaster that will be applied to it, except we are saying that the partitions is not going to have any form of plastering, which is not correct. So the unit weight of a plaster is 0.6 kilonewton per meter squared. Is 0.3 kilonewton per meter squared rather. Now remember that you're going to plaster both inside and outside. So 0.3 plus 0.3 will give us 0.6. Now 0.6 plus 2.87 will now give us 3.47. So this one is what? 3.47. That is the unit weight. That is a combination of the plaster and the partition. Now remember I told you that the headroom of the structure is 3 meters, but I'm coming. Let me show you something. Okay, there's no way I can. Okay, very good. Now, where's my calculator? Let me show you. I want to show you something. Okay, let me bring it back. So we have a calculator here. Now, 3,000. Now, remember I told you that now the beam is a 450 beam, but for a 450 beam, 150 is going to flush with the slab, while 300 is going to drop. So it will now be 3 minus 300. That's 2,700. So for this place, we are going to put a 2,700 height for the partition. Now in Nigeria, the thickness of my block is actually 225. Then plus plastering and stuff, then we can just say this one is 230. Are we together? Then after you've done that, then you come to this place. And click. Let's make it bigger. Then you click on update and you will now click on what? Sorry, I actually inputted 3,700. That is wrong. You click update, then we'll click on OK. sorry, that's wrong. So let's do it again. Edit load, wall load. Okay, now it's set now. So click on this, click on update, then click on OK. Yes, very good. Now let's look at architectural drawing and let's see the places that we have partition. Let's see. I'm coming. So you see that we have partition in almost all the block works. That's why we have partition. We have partition in almost all the block work. Apart from here that we have something like a glass. But we have partition in almost all the block work. So what do we do? So we'll come to this place, click on this. We'll now click on what? Copy load. Okay. Now what you do is you select the first one, then you come to the last one, you hold down your shift key. Let's go. Okay, let's do it the other way one. You select the first one, you hold down your shift key, then you go to the last one to select all the beams on the model. Then you now right click, then you now paste load. Voila. So the wall load has been added. Now let's look at what we've done on the 3D. Yes, very, very good, very good. Can you see that the structure is actually coming out very fine now? It's actually coming out very, very nice. Now the next thing for us to do is to try and now let's go to insert story now, because now remember I told you that the structure is a one-story building. It is having one suspended floor, but the software actually sees the roof as another floor. So that is why we're actually going to make the number of stories to be 2. So we'll click on this, then we'll click on OK. Are we together now? Click on OK. Now let's now go to edit story. It has been set. Why? Because I told you that the headroom is actually 3 meter, and what we have here is actually 3 meter. So you click on OK. Very, very good. Everything is coming out very, very fine and very, very nice now. Now the next thing we need to do is to generate story. Okay, let's look at it at the 3D. Let's look at it at the 3D. Yes. Next thing we need to do is what? Is to generate story. That means we want to generate the roof level. Now remember I told you in the part 1 that these two columns here are going to move to this edge. So this beam is now going to be a transfer beam. These ones, and these ones. Now, very good. So let's now insert the story for the roof now. So let's go to, let's generate rather. So let's go to generate story. Now, the roof is not having a slab. It's not having a slab. It's only having the roof carcass and the aluminium sheet. So let's just delete. So let's remove anything that has to do with slab, bracing, yes, shear walls. So let's click on story 2. Then we'll click on OK. Very, very good. Very good. Now remember that this wall load, we actually brought it from the first floor. So we don't need any wall load on the roof. What we have there is just the roof load. So what we are going to do is this. The same thing we did before. We click on beam. Let's copy all the beam. Select the first one. Hold down your shift key. Select the last one. Right click. Then you now look for delete load. Look for delete load. Let's delete the wall load. The load has been deleted. Now, because it's a roof, it's a rectangular beam, it's not a flange beam. So what we can do is to make the roof beam to be 300. Yes, let's make it 300. It's just a rectangular beam. It's not having any slab. It's not sharing any slab load or anything. So let's now change this. The same thing. Press the first one. Hold down your shift key. Go to the last one. Go to edit material section. So change this to 300. Change this to 300. Then you click on OK. You can see that everything has now been changed now to 300. Now let's look at it on our 3D model. Yes, we can see now. You can see that the structure is actually coming out very, very nice. Structure is coming out very, very nice and very, very fine. Now, the next thing we need to do, like I said, is what? Now let's move this now. Yes, let's move this. Let's click on this, then right click. Okay, let's do it one at a time. Let's place it here. Yes, let's move this also. But because of time, let us insert another one. Let's go to properties, insert. Let's insert. Now let's come here. Let's insert. Let's insert. Okay, very good. So we can now delete all these ones now. And delete all this. And now delete all this and delete all this now. Yes, we can now delete all this now. Let's see. Now, like I said, if any of the beam fails, we can increase the section of the beam, because I'm looking at the span of this. So we need to delete this now. Yes, we need to delete this. Those columns are actually there because of the roof. Because the roof is definitely going to project out here. So we need a column outside there to actually support the roof out here. Are we together, please? Yes. So these columns are actually going to terminate at the first floor. So the same thing here. Let's delete this. Let's delete this. Let's delete this column. Let's delete this column. Let's delete this column. So let's go to properties. No, don't break it. So those beams are actually point load and acting on it. Don't break it. Very good. Very, very good. See that the structure is actually coming out very, very fine and very, very nice. So let's delete all this. Let's delete this. Yes, let's remove this column also. Yes, very good. So you have properties. Let's bring it straight down. No. Yes. It's possible for these beams that are having a point load to fail. Can you see? To fail at 300. But if it fails during the analysis, we are going to increase the section. But for this video, I just want to show you the principles in modeling. Okay, so yes, let's delete this also. Let's delete this also. Let's delete this also. Let's go to properties. Then let's take it up. No, no, no. Very good. Very, very good. Yes, yes, very, very good. Now, according to the code, according to the BS code, what the BS code says is that the roof load should be what? 2.25 kilonewton per meter square. That is factored. That is what the code says, 2.25 kilonewton per meter square. So we now need to model the roof load on the beams. We need to model the roof load on the beams. And how do we go about that? So, sorry, this is not supposed to be here. Okay, okay, yes. Very, very good. So we need to model the roof load on the beam, which is what? 2.25. But the 2.25 is what? Factored. So unfactored is what? 1.5. So we now go to what? Edit load. Then you go to wall load. Now, remember I told you that it is what? 1.5. So let's make this one 1000 and let's make this one 1.5. Once you do that, you see that the load that the beam is going to be carrying here is what? 1.5. So you see, you can see where my mouse is, 1.5. So then you click on OK. Are we together? So the roof load has been modeled. The roof load has been modeled. Now the next thing we need to do now is to now click here, copy load, OK. Then come to the beam. Let's come to the beam. Click the first one, go to the last one, then you paste. Let's paste. Very, very good. Very, very good. We're almost coming to the end of the model. Very, very good. Very, very good. So let's look at our 3D. Can you see? Can you see how nice the structure is actually coming out from? This is actually a live project. It's a live project that I actually did for a client. And the project is actually based in Abuja and construction has started already. So I'm not teaching you a project that's not a live project. I'm actually teaching you I'm actually using a live project to teach you. And most of the trainings I'll be doing here are actually going to be live project, be it for steel or for reinforced concrete. Now, very good. The next thing we need to do now is to do what? Is to check our model. You go to analysis, you go to building analysis, then let's go to building model check analysis. Now let's go to building model check. Then you click on analysis. Can you see that our model is perfectly okay? There are no errors. There are no errors. Now, let's now set our rebars and our foundation now. So let's come to settings, setting center. Let's go to setting center now. Let's go to setting center. Then let's now go to first things we need to set is the column. Let's look at it. Let's look at it. Yes, so we won't have issue of shear here, but let me just click on double link. Now let's go to longitudinal bars. I want my column bar size to be a minimum of what? 16 and a maximum of what? 25. Maximum of 25. Then let's go to the links. My links, I want it to be 10 mm. Then I want my link spacing to be a maximum of 250. I don't have walls, but let's just make this 250 also. I don't have walls, let's make it 250. Now let's go to beam. Let's go to the beam detailing. Let's go to the beam detailing. For the beam detailing, the minimum beam diameter, let's make it 16 mm. The maximum, let's make it 25 mm. My link diameter, let's make it 10 mm. Let's make it 10 mm. Then my angle pass through 10 is okay. And let's go to the let's work on the links. The minimum should be 250. The minimum link spacing, the maximum link spacing for the support 250. Then the maximum spacing link for the span also 250 also. Let's make it 250. Then let's click on what, so it has been set. Then let's come to the let's come to the slab. Let's come to the slab. Let's come to the slab. So we'll be setting the slab, we'll be setting the foundation, setting the slab, we'll be setting the foundation, we'll be setting everything. Then before we now go and run the analysis. So let's go to the slab now. Let's go to the slab. I want my slab to be a minimum of 12 mm. A spacing of, I want it to be at a spacing of 200 mm. Are we together now? Then we can leave the rest. Appearance, yes, it can appear. It can show number of bars, there's no problem. Now let's go to the foundation. Now the soil test report says that the bearing capacity is what is 150 kilonewton per meter squared. So I put 150 kilonewton per meter squared here. I want it to be a square column. I want it to be a square column. I'm not doing a combined footing, so I do not need a top bar. I want it to be a minimum of 16 mm. Yes, it's okay. I want it to start from 300 up, which is perfect, which is okay. It's perfectly okay. So I think I'm through with my settings. Now the next thing I need to do now is to go and set my concrete. Now it has been set. Now let me go and set my concrete. So let's go to analysis. Let's go to building analysis, edit materials. So I want my steel grade to be 410, which is okay. Then my concrete, I want it to be C25. I want my concrete to be C25, which is perfectly is in C25. If you want to change it to C20, just come and click here and come to this characteristics compressive strength. You see, but I want it to be C25, so we'll click on OK. We'll click on OK, then we close. So I believe we are through with the modeling now. We are through with the modeling. So what is left now is for us to now run the analysis. Let's run the analysis. Now, if you want to run the analysis, let's go to building analysis. There's something I do here. I make my beam to be a flange beam because it has slabs sharing, so it's a flange beam, it's not a rectangular beam. It is most times the roof beams are rectangular beams, but for beams that are supporting slabs, they are flange beam. Now that is that. So let's now run an analysis now. So let's go to building analysis. Let's go to building analysis. Now when you check this, that means you are telling me to design the column, to design the beam. Now when you check this, you are telling me that it should redesign, select the bar. If it fails, it should use a bigger section. Now let's click on building analysis. So let's wait for it. It's going to run the analysis of the columns. It's going to run the analysis of the beams. It's going to run the analysis. I will show you that of the slab. I'm going to show you that of the slab. Come here, let me see. Okay, I'm going to show you that of the slab. Now it's designing the columns now. The columns are being designed now. Yeah, so let's click on yes. Now it's true with the design of the column. Now let's look at the design of the beam. Let's look at the design of the beam. So you can see that we have some beams that are failing, we have some beams that are passing. We have some columns that are failing, we also have some columns that are passing. So it's the relative story drift satisfies the limit for both direction 1 and direction 2. So that means our vertical structural elements are actually sufficient. Now, let's now go to post analysis now. So let's go to building analysis, then let's click on post analysis. Or sorry, let's come this way. Let's click on review, go to visual integration, and let's click on design status. Okay, I have a beam failing here. I have a beam failing here, and I also have a column. I also have a column here failing. Now let's try and fix this beam. It's just this beam that is failing. So let's click on this beam. Let's click on this beam. Let's click on this beam here. So let's click on section design. So it's even good. So I can even show you, I can show you how to fix a beam that is failing. So first thing we need to do is to check the reason why it's failing. So the first thing we need to do is what? Let's try and reduce. It's actually failing in shear. So let's try and reduce the spacing of the links. Let's see, it's failing. What it's trying to tell us is that we need to increase the section, because we've actually tried increasing try reducing the link spacing. So you have 1B36, 1B36. So you click on beam. Okay, this is 1B36. So let's make this 600 and let's see if it's going to pass. Let's go to beams. So you see that it has passed. You see that it has passed. Then we'll click on OK. So let's see. I don't know why it's not. It has shown that it has passed. Okay, let's update this. Very good. So let's click on OK. So you see that it's now green now. You can see that it's now green now. So let's go to the column now and let's see why it's failing. Let's click on the column and let's see why it's failing. Okay, this actually failed because of the software. The software does that at times, is that it did not design this column. Don't worry, I'll show you how to go about it. Now let's go to the next floor. Let's go to the second floor and let's look at the structures that are failing at the second floor. Okay, you see that everything passed. Everything at the second floor passed. The beam passed, the slab passed, the column passed. But let me show you how to do this in case. So what you are going to do is this. Because you didn't design it, so we are going to delete this and run the analysis again. I've deleted this. So let's take this column, place it. Let's go to properties and let's place it. Are we together? Now let's rerun the analysis. Go back to analysis, building analysis. Let's rerun it. You see that column now is going to pass now. Let's click on building analysis. Let's click on building analysis. Let's wait for it. Let's wait for it. Let's wait for it. Let's wait for it to run its analysis. 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 Then we will now check if that column is still failing. Check if that column is still failing. Check if the column is still failing. Like I said, this is a live project that I did, and the structure is actually under construction in Abuja. So you have it passing now. Can you see? You have it passing. So you have everything passing. You have the beam, the slab. Everything has now passed. Very, very good. Now, let's now see, because I don't want it to. Okay, let's now slab now. Let's work on our slab now. The slab now. So let's now check if any of the slab is actually failing in deflection. So you will now pick the slab strip. Let's pick the slab strip. Yes, the end condition is actually, this one is telling you are starting from a beam and you're also ending at the end of the beam. That is beam to beam. So you bring this one is stopping here. So you hold down your control key and you drop. Yes, you see, this is what is actually providing, but don't worry, I'll show you how to go about it. The software does not have 12mm. What it has is 13mm. You could remember that I actually selected 12mm, but it's showing 30mm. But don't worry, we would actually show you how to go about it. Then this one also, bob to bob, that's beam to beam. So drop it here. If any of the panel fails, the software is going to tell us that it fails. Now let's come to this big panel here, this big one here. and let's see if it's actually going to fail here. So hold down your control key, drop it here. You see that it's not telling us that this panel is failing. But let's continue. Let's come to this one also. Let's come to this one also. Hold down your control key and drop it. Are we together? Now let's come here. Let's come here now. Okay, you come and change this to Y, the same bulb to bulb. You come and drop. Are we together? You come here and you drop. You come here and you drop. You come here and you drop. So what this is actually saying is that none of the panels actually failed. All the panels passed, but what the software is providing is 4 But don't worry about that. It's 13 I'm gonna show you how to go about this. Now let's check if our slab has passed also. So this is what you do. So you come to design, you click on slab analysis and design. You see that everything has passed. Everything has passed. It is not going to be telling you the panels. See, it's telling you the panels passed, it's telling you the panels has passed, and it's telling you the area of steel provided and the panel has passed. Then so we cancel and we cancel. So we have come to the end of this lecture, which is the modeling and the design aspect. Now, the last class is not going to be the detailing aspect. I'm going to show you how to detail slabs and beam, easy way in detailing. Thank you very, very much for this thing. But first things first, let us design the foundation first. Let's design the foundation first. I wanted to shift the foundation to the next class, but let's design it because I don't want the video to be too long. Let me see. Okay, let me end the video. For the next class, I'll be starting from the foundation. Then we'll now enter into the detailing aspect. Or let me design the foundation. Let me design the foundation. Now, for the foundation, you will now go to story 0. I want to show you a very easy way in designing the foundation. Now, for me, I want to divide it into two. So, okay, remember these ones are actually. So let's select this. Let's select this. Remember that it's actually semi-detached. Let's select this. Yes. So let's leave the one in the middle. Let's leave the one in the middle. So what I want to do is that I want to have two base type. So you right click and insert part footing. Once you insert part footing, it's going to bring out a dialog box of everything I selected. After that, then you now click on check design, redesign if fails. Then you click on design all. Like I said, I want to have just two base types. Okay, we have some that are failing. Not to worry. So what you're going to do is this. Select the first one, hold down your shift key, come down to the last one. Are we there? Okay, we still have some. Select the first one, hold down your shift key and come down to the last one. Yes. Then you click on group selected. Are we together? So everything has been selected and everything has been grouped. Then after that, we now come and just select. So you just click anywhere, just click outside. Wait for it. Let's wait for it. Let's wait for it to come up. So it's actually gonna take all the part footing and pick the worst case scenario for everything. Okay, it's actually giving me a depth of 600. I believe that is too much for a one story building. So let's cancel this. We're not gonna go with this method. Okay, let's have like 3 or 4 base type. So what we're gonna do is that in the next class, we are gonna design the foundation first. Then we'll now go into the detailing aspect. Yes, thank you very much.